So this summer I worked on generating a randomized image that was representative of bone structure. So the goal of my project was to create a process that would generate a two-dimensional bone structure that represents healthy and mature bone. So this figure shows the result of my current process. And this project is important because it allows us to get a better understanding of the microdamage healing process, as well as predicting how cortical bone will react under different levels of stress. So some background. The cortical layer is this layer of bone, and it's in between the bone marrow, which is over here, and the outer layer of bone around the edges. And it's composed of cylindrical units called osteons that are made up of concentric layers of cells with a room in the middle for blood vessels called the Haversian canal. And osteons are responsible for bone's resistance to fractures and damage. And so then as people age, they do accumulate microfractures and damaged bone, and that bone is replaced via a remodeling process where new osteons form on top of the older bone. So before I started this project, I had never done very much coding. So I started just drawing circles here, and then I realized I needed to be able to do more complex things with them. So I switched to Shapely, which is a geometric processing package. And it allowed me to represent the osteons using polygons, which approximate the circles that I had been using. And then it also allowed me to perform various operations on them that would let me display them. And then I expanded on that by adding more osteons and also adding another polygon that would represent the central canal. So this is my procedure that the code goes through. And so in the first column here, we pick a radius, and then we also choose a location. And then over here, we actually generate the osteon, and then we also generate the layers of the osteon in rings from the outside in, because that's how osteons form during the healing process. So the results of my code, on the left, you can see this is the image that is displayed after the process. And the yellow represents a fracture. And then the purple represents a bone surface if you took a cross section of cortical bone. And then the red circles are osteons. And you can see the rings are generated, and they're generated from the outside in, like I said. But they're also Shapely's used to perform operations so that they can look like they're layered on top of each other. And then on the right, photo of real bone, where the white outlines show the cement lines, which are the outer edges of the osteons. So the process results in an image that represents the microstructure and also mimics the remodeling process of healthy bone. And the osteons have a higher probability of generating over the fracture area, because in real life, osteons will generate over the damaged areas at a higher rate. So improving how the algorithm reacts to this damage is also going to be a major point of study in the future. So fully simulating the remodeling process by including damage that is more representative of the microdamage that accumulates in bone will lead to a better ability to predict how bone will react to different levels of stress. And then other improvements to the code include spacing out the osteons and stopping loops. So in conclusion, my current process will generate that represents cortical bone structure, but more work is needed in order to fully simulate the remodeling process. And some ways to better simulate the remodeling process are creating a new spacing osteons, especially spacing out the ones that cluster over the fracture area, and also creating fractures that aren't the same every time, so that when the code runs, it has to be able to change. And then that's it.
All right, thank you, Kalina. I'm sure everyone is applauding. Judges, let's go, Dr. Constant, if you want to start, and then we can move to Dr. Lima and then Boz. So any questions?
Okay, go back to the slide that, if you can, go back to the slide that showed the photo of the bone cross section. There we go. Thank you. So my question is, when I look at your model and I look at the bone structure, it appears that the actual zones do not overlap, but in your model they do overlap.
Mm-hmm.
Is that
Okay.
correct? Is my assessment
Yes.
correct?
So on the right, the photo of actual bone is a photo of horse bone. And so horses have they don't have a lot of primary osteons. So nobody really knows why the osteons in this bone are all spaced out like this. But the osteons do overlap, like they can, like is shown in this.
Okay. Maybe that's why when the horse breaks its leg, things don't end well. I don't know. Okay, that's what I was. So to improve do you need to improve? Sorry. What do you need to improve again about the modeling of the channels and how they overlap?
So currently you can see over the fracture, they have a tendency to all generate right on top of each other. So they are replacing the old damaged bone, which is represented by the yellow. So, but just spacing it out more, just like even so they still overlap, but not quite as much, would help to make it look a little bit more like the picture. Yeah.
Okay. Thank you. That's all I have now.
Thank you.
Thank you, Dr. Constant. Dr. Lima?
Hi, Kalina. First, I want to really congratulate you on an outstanding presentation. I felt like it was really clear, and I know it's always hard to be the one who goes first. And so I really commend you for what I would consider an outstanding presentation that's really well organized. And of course, you know, the way that these poster sessions go, which I'm sure Dr. Melvin had already told you, is you do your presentation, then you get peppered with questions. And I know being the first one to address those questions can be difficult. So I'm actually going to give a signal to the other students who are going to present later in this hour that I'm going to ask the same question of everyone, either one or the other if there's time. So the first one is, what did you learn about research through this process that you did not know when you started earlier this summer?
That's a good question. So I learned a lot that research isn't just like you start and then you go and then you get to the end. There's a lot of like different avenues that open up when you start looking at stuff, and you open up new questions and you have to like redo stuff and try again. Like I ended up rewriting the code to make it be different like several times.
Okay, and what did you learn about yourself from doing research this summer?
I learned that, well, I like doing research. I like this kind of research where it's not like the stuff that we have to do in school. And I also learned that I like to do it. Yeah, it's fun.
Okay, do I have time for one more quick one?
Yes, you do.
Okay. Why is that ability to predict how the bone reacts to different levels of stress? Why is that important?
Like predicting how? I didn't hear the first part of your question.
Yeah, so you talked in one slide toward the end of your presentation about how it's really important to be able to predict how bone reacts to different levels of stress.
So as we age, oftentimes people's bones become unstable. And so if you were able to tell like, oh, like this person has if they have, say, osteoporosis, you would be able to say, oh, well, avoid this kind of stress, or you would be able to know how the bone would react if in certain circumstances.
All right, great answer. I'm good. Thank you.
Dr. Lima. Boz?
Dr. Lima took my question with that last one. I did also want to ask you though, I talked to your group about presentations, and here we are in this strange environment. What do you think the biggest factor, or maybe the biggest challenge with presenting in this COVID environment with everything being remote? How do you see that being fundamentally different than maybe what you expected when you signed up of giving a face-to-face presentation?
Yeah, so when you give face-to-face presentations, you're like talking to somebody, but like over Zoom, I'm just talking to my screen. So it kind of feels different, and it's also hard. It's harder than in person, because in person you're looking at a person's face, but here you're like looking at your screen and all the information that you have to say, but you don't want to read it.